So this is a bad design. This is a good system design. So I will tell us in this video, at the end of this, you'll be able to understand while building your back end design this way using only APIs, right? Is a very dangerous move, when you want to build a reliable back end systems, right? And building your system this way is a very good, reliable system model when you want to build a good back end reliable systems, right? Especially systems where money movement happens, right? And that's where mistakes are very, very expensive. Why where this kind of activity is not really allowed, right? So if you're seeing me for the first time, my name is Obina Victor, and I actually focus on building reliable products, right? And I care a lot about what happens after a request is being sent, right? And my work focus majorly on reconciliation, reliable products, distributed backend systems, AI agents, and the likes, right? But so now let's dive into this proper, right? Let's dive into this topic proper. Um, so I want to title this. I don't really have a very specific topic for this, but if you want to title it, I'll title it the boundaries between an API and a an execution system, right? That's what I'll title this. So now for a second, right? I want us to forget everything about any programming language at all. Be it Rust, be it Java, be it Go language. Just forget about any language, TypeScript or whatever. Forget about it for a second. Let's focus on understanding the mental model behind building a good backend system, right? And so this is one of the topics of many ways of building a very reliable backend systems, right? So now, when a normal beginner, right, wants to design a system, right, a back-end system, right, they focus majorly on a user sending or a client sending a request, right, and the system doing the work, and the system returning a response to the client, right. Now, this is the pattern here, right. This is the poor design pattern. And if you look at this pattern, it's very, 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 very poor, right? But if you're looking at it from a very broad distance, right? If you zoom out of it, you think that this is a clean system design, right? Where you send a request, right, and you validate the request. The API also calls the provider. The API saves the response, and the API returns the success of failure, right? Now, let's zoom into this for a minute, right? Now, when you talk about an API, what is really an API? An API is just an application programming interface, right? Is what gives two systems access to talk to each other, right? And so this is the client connecting to your server, right? And so there is a temporary connection between your client and the server for requests to come in, right, to your system. Now, just follow through, right? So when this request comes in, right, client sends a request. So the request might be refunding um, a user, right? You want to refund the user, or you want to refund somebody their money, maybe because of they didn't later order, or the product they ordered didn't is not actually available in the store, or whatever reason, right? And so you want to refund this user, or you want to make payment, or you want to send payment, or whatever, right? So the client sends this request, right? Now, what happens here is validation, right? and um, this validation is the sole um, role of the API, right? Is to validate. Now, the API also calls a provider, right? And also save the response of the provider, and at the same time returns a success or failure message. Now, let's just zoom into this a bit, right? Now there is an activity happening between this guy and this guy, right? This is the client and your AP, your server connecting, right? This is a temporal state. So now, if let's assume now that this sends a request here, there is a connection happening here between these two guys, right? And this API, the API calls a provider because there's already an information that needs to be run, right? It calls a provider, and in the process of calling the provider, the client disconnects from this guy, or this guy crashes, right? Or this guy crashes, or the provider even wasn't responsive enough, right? The provider didn't respond on time, or the provider is down, right? Or the provider is just bad for any reason actually, or even self the provider is good, but the database that needed to save the provider response didn't is failing, right? Or even the webhook listener came in late, right? How will you handle this request? Now, the downside of these questions actually you'll be asking here is that if a request comes in, right, and this guy validates it and is calling a provider, right, and there is a disconnection between the client and the server, right? There is no proof, or there is no way to actually retrieve this information or to know the information that is being called if anything goes wrong here, right, between the your server and the provider. Because here is the tricky part, because you cannot guarantee that an external um, provider or external call is always active. You cannot guarantee that it will respond on time. You cannot guarantee that your server will actually wait it out, right? Where we have to now talk about timing out, right? Or where we start talking about unknown outcome, right? You cannot guarantee that. And if this thing actually happen, you cannot still guarantee that the API can be able to save, since maybe let's say your database was down, right? This thing I've sent this already. I've sent this to the API, but because the database weren't able to save this, you cannot be able to send anything to the client, right? And the client might want to resend this request again, which is very, very expensive, which is very, very, very expensive, right? This is the bad design of this, right? It might not mean much maybe when you're charging, maybe you want to refund 10 naira or $10, right? But imagine you want to refund 8,000 or $50,000 to a client, and the client, you're sending this request twice to refund the client. The client will be going home with $100,000, and especially when if this is a crypto address that you're trying to send this thing to, almost is a good, like you're gone, right? This is a bad system design. Now let's look at this a bit. Now this is a good mental model when you want to design a very reliable back-end system, right? Now this if you're zooming out of this, you see that you think that there is a lot of activities going on here, right? But this is the correct design. This is the correct guy here, right? Stay with me please. Now this is what is happening here. A client sends a request, right? Your API captures the request, right? Your API, the system validates and authorizes the actor, right? So validation and authorization is to ask questions like, who is this person? Are you authorized to actually make this request? What request are you actually trying to make, right? These are the kind of authorization question that is being the system is being asked. Then idiopotency and correlation IDs is actually used, which is very, very important. Right? What this thing helps is for duplication. Right? So if for any reason the clients want to send this request twice, resend the request again, this guy here will check if this request we have already seen such a request before. Right? If you have seen it before, we just return the result. Right? Now, this the system actually persists the command, right? Now, what happened here is that what persisting the command does is just that the API actually converts this request into an action that can be stored into the database, right? That's what is happening. So after this validation happens, and all the security measures are being added, right? Is being this command this request is being persisted to the database, and just by normalizing this request to an action, and it's being persisted to the database, and um, a job record is being created. So what this job record means is just that you're queuing these jobs into the database. So they are in queues. And so what queue means is just that they are in a line trying to be used or trying to be worked on. Right. So requests are jobs. Requests are jobs in the database. And so there might be like 1,000 requests coming in, so this might be the third request. So it will be queuing in. The first one will go, the second one will go before this one we have to run, right? Now, when these have been queued in, the API returns accepted and processing. That's 202, right? It doesn't literally returns that these requests have been successful. No, what the API is returning that is that that this request have been accepted and is under process, right? This is where the work of the API should end as touching your back end product. This is where the work of your API should end for now, right? This is where the work of your API should end. Now, what happens when these jobs are being queued, right? Now, background workers actually picks up these jobs, right? Um, um, which is being called leasing, right? You pick up the jobs, you log the jobs. A worker logs a job that okay, I'm already or I'm working on this job. No other worker can be able to work on this job, right? And a time the worker is being timed, right? If you exceed this time, this job will be stripped from you and be requeued, right? That's the design pattern. Now, immediately a background worker, a worker actually picks a job and starts working on it, right? The worker actually creates what we call an attempt record, right? And what this attempt record does is just to keep track of this intent, right? Keep track of what is happening in under the hood for this particular intent. So for each intent that each worker actually runs or try to execute, an attempt record is being created, right? And what this attempt record does is just to keep record of what is happening, right? From how many attempts happen. So attempt here is trying to execute. That's what it means. That's what attempt means. I'm trying to execute this thing. How many times did I try to want to execute this thing? How many times did it fail? What was the failure mode? Is it a timeout or is it a fatal failure? Is it a day later? Did the what exactly failed? Right? How what was the failure mode? Right? What's the failure classification here? Right? Um, and now the better design is that if you can put that each worker can attempt to create or attempt to execute a job or attempt a job for like 5 times, and if passes that limit, it should actually be pushed to retry or pushed to be retried later, or if it continues to fail, then is a day later, or good classification should happen here, right? So now the worker also performs execution. So what this execution it means is just that it pushes it to the provider and still check the provider whether this thing is being done, right? And still, as this is going on, The attempt record is also keeping track of what is happening, right? So the system records provider and result evidence. So this is different from data log, your log system. Log system is for debugging. So what this evidence shows is just it shows a receipt of the life cycle of this intent, a detailed receipt from how many attempts did we succeed, did it fail, did the provider provide a good result, or did it not provide a good result? What is the outcome? Right, you're seeing the life cycle of this intent from the point where a worker picked it up to start working on it, right? And this is system classification of outcome. We classify the outcome because now there are different outcomes that can actually happen, right? And different outcomes can be timed out. The system timed out. Um, there is a network downside. Doesn't really mean that there is the your system crash or whatever. There can still be a system crash or a try storm or whatever reason. Right. So this classification is important than only putting success or failure. This is a very bad design because um, failure can here is just that you're packing up all failures into one failure. So even if it's a timeout system, a timeout happen is a failure, and your system will want to retry. So what happens here with this kind of design is that when you are calling a provider, right? Or let's say use this beta design. So let's say you classify this with only just um, success and failure, right? Now the worker called the provider and the provider is trying to execute it, but the worker timed out because of the timing that was given to the worker, right? It was waiting for the provider, but the provider didn't respond on time and they timed out, right? Um, because you actually added, you just classify your errors to failure and success, the system will automatically return that this action failed, right? And not knowing that maybe the provider have already executed this system, this thing, right? The provider have already executed this, have already refunded the person and is giving you feedback, but because you timed out, your system have already returned failure and you have given the feedback to the client, the client will want to try to resend the same refund again or payment again or whatever, right? We also have replay, we also have yeah, we have replay, we have video buttons, we have dedups, we have a lot of measures, but what I'm trying to focus on is the API boundaries and the execution system, right? So this is now reconciliation. This is if the truth is unclear. So this comes into play when you actually have a good classification. So this good classification helps you to reconcile much more better, right? And now this is where you now try to expose the users and the operators, right? So this is how you design a very good reliable backend system, right? This is not a good part when you want to build a reliable system where mistakes are expensive. This is the better option. This is better process. This is better route to go about it. So this actually comes into play whether you're using Java, you're using Go, or you're writing in Rust, right? You're writing in TypeScript or Node.js. It doesn't really matter. What matters is that this mental model is stuck in you, right? So now there are different layers to this, right? So the AP this is now the API rules. This is just a brief explanation of the API rules, right? So API shouldn't go beyond this. So from the point this is being queued in, API rule stops, and when it's being queued in, the API return an accepted response, which is 202. That this have been accepted, the intent has been accepted, and is being processed, right? Now, this is me talking about the layers, right? So this is the beta layer, request intake, durable command, persisting to the data